Oh, yeah. I'm making a local reference here to the pointer, and then the reset resets it. And I was still using this one. Okay, the old pointer. So after this break, we're also no longer allowed to use that, and I am like here. Might as well just grab this. Yeah. Yeah, I guess now it works. So. Okay, it's unclear, right? Let me just quit this thing. Boo, what the hell happened there? Yep, missed it. Okay, this is an extremely difficult one, I think. Jumping back that far is kind of nonsensical. Now think about it, jumping back is nonsensical, period. No, actually not. I want to jump to the vertex, and then I should be allowed to. See, if you have a little overshoot, then you should allow to jump to the vertex by going backwards. Actually, find it. But what just happened was we're trying to find the vertex of this parabola, and then we fit this parabola. that jump all the way there. Should be able to detect that. Let me just look at that again. So it alternates between minimum and maximum, and it's going to the left. Minimum again. Now it made a big jump. This should not be allowed. It should backtrack. I didn't code that yet. And then find that one, and then that, and then that, and then that, and then that. Well, might as well skip it. So now you jump there. And then we find this minimum, which is good. And this is also actually backtracking, or not sure what's happening here. Best zero is at minus 32. Huh, what? Oh, it's going backwards then? Yeah. Yeah, well, that's true. I mean, if you're in this point, then clearly the best zero is there. Is it? Because it's increasing in amplitude. I think the detection of this thing here, rather. This is the maximum. So looking at the curve here, it says that that maximum is going to be lower than that maximum. However, I already had that maximum and I want to go to the left. So it should never have said that you need to go to the right. Best zero. That is not correct, man. Oh, the other zero is at minus 3. Oh, what? But it's 0. That's here. Ah. Yeah, I think that both zeros are on the right. And then I pick the leftmost zero, which is here, blindly, because I assumed that the zero is the zeros are left and right of it. So what really is that I should treat it as there are no zeros, because even this zero is on the right. Interesting. Never even considered that. like this kind of code. It is simple, but there's a lot of symmetry. So we go to the left. And this 0 is on the left of W, then it's okay. Yep, and I have to fix the zeros. Array. What is with the less than or equal? What the hell would that be equal? Yeah, that was a bug, I think. Okay, so if it is just the last zero, then just decrementing it is enough, because then this will fail. And then we escape anyway. If it was the only zero, then it is the last zero. So the only thing that I'm interested in is when 0 equals 1 and number of 0 equals 2. Which means that I can start testing this. If there's still 1 0 left and the current 0 is 0, then actually the array must be fixed, as in zeros. 0 must become zeros 1. Yeah, so if both are on the wrong side, then the first time I move the second one to the place 0, and then we test that one, and it is then also on the wrong side, and then this is true again. No, it's not true again. The first number of zeros then becomes 0, so then we don't do anything. Then 0 is not less than 0, so we exit this. And then number of zeros is 0, in which case we end up with no zeros. Ta-da! Let's see if that works. Meg. That worked. Now it says no zeros. So now we go a little bit to the left. And we should keep going until we leave the parabolic approximation, if I still have that. I have it. So we go to the left. Then we left the parabolic approximation, so now we go back to a straight line. And then it should still keep going. And it went way too far. What the hell? Continue same direction. Oh, wait a minute. I just reset the scale. Did I? Didn't I? It should have made a small step again. What the hell? Why? This already does not make any sense. One simple same direction. Minus 66. Yeah, that's the one that I just saw. This is the one that is failing. So here it still makes sense. A reasonable small step. That doesn't make sense. I mean, let's start debugging from this point on. And let's see what the hell we do. We get minus 66. Debug output is not very clear, but from this line I can see that it called some function which actually I should have added specific in the debug output, I think. Can still do that. Disconnect. At the very least. And that this was entered. Probably also should print a return value here. Just put it on one line. So I have an add or approximation add, which is here. it? Isn't page, no. It must also be inline. Stop too early. Indeed, never give up. And I'm making progress, of course. Hello, Hobiku. Okay, here's the weird value. So why did that happen? So I tried this, it detected that it did not fit the current approximation anymore, and therefore we return disconnected, which then causes a reset, forget all previous samples. And now the approximation is just a linear line. Apparently that line then incites me to make a huge step. Why? Yeah, I wanted to have a breakpoint like let's say wondering if I should put the breakpoint before or after this ad. Maybe we should go into it. I don't think much happens, but you never know. So let's put a breakpoint here around the scale. Reset. Which is in the neighborhood of the disconnecting. Exactly there. So I want to step into this ad, I suppose. Let's just do debug here. Attach debugger. Oh, wait a minute, that's all too soon. Say no, quit, yes. No, suppose this is it. What kind of annoyance is this? Oh, it's because of this continued. Can't print it yet. But this is the value, right? That what was it? 48 minus 48 something. Minus 49. Yeah, okay. The what is sworn it was 48. What the hell? This is now it's 49. It has been 49 all this time. Okay. Hey, now what? It's not replacement, so we add it to the relevant samples. Dropping another one out. We are updating skill only, however, I think, or no, I just passed false. So this is 1, no, or 0, 1. Set the straight line. Not print it. Jesus Christ. So the problem is that, I mean, it seems to make no sense if you ask me, but or it's rather arbitrary. Let's put it that way. I have some scale here for W, and I have some scale here, and if I multiply the Y scale by 1000, it's still the same problem. But apparently it makes a difference, or at least I should have changed my learning rate, I guess. But the thing is so arbitrary. So because this is a huge, this difference, more than 1,000, 1,400 total. And we have a line here which is super steep. And then the learning rate is 0.1, so 0.1 times the enormous whatever, and then we make a big step. Yeah. Really? I think I should adjust the learning rate automatically sometimes. What about every time I find an extreme, I set it to something that is real, that relates it to the parabolic approximation that makes it reasonable. Because it's that the 0.1 is like super arbitrary. Yeah. I need the formula to set the learning rate from a parabola and its scale. What is that formula? How shall we do that? The interesting thing here is that the whole learning rate thing is nonsense to begin with. I don't think I should ever use it. I think I'm going to do away with learning rate. I don't want learning rate at all. It just doesn't make much sense. Although Let me think. Yeah, well, no. Well, I think learning rate has to do with the algorithm that a lot of people, aka most people, use in order to slow down when you get to in the neighborhood of a minimum. So they picked something linear with the derivative, meaning that if the derivative is 0 because you're in a minimum, then you don't move anymore. But I completely replaced that with my own algorithm, so I don't need a learning rate anymore. What I do want is that at the moment that my algorithm has no idea what to do, that I make a small step. And then I mean a small step. I really don't care if I'm in a maximum or in a minimum or somewhere here. I always want to make the same step horizontally. I think what I did is do something like learning rate times the scale. That would make sense. No, I'm just adding the scale. That's what I'm doing, yeah. But okay, this is a one-dimensional case. So in the end, we have many dimensions. So it's a multi-dimensional space instead of one dimension, and then it's not that simple anymore. So now I could pass like a step of 1. So you change W with just 1 is reasonable. But now I have only one W value. If we have many W values, then it might be that the other W values require a different step size. An automatic calculation would be preferred, I suppose. Yeah, because you just can't pass anything. It's so arbitrary. You have no idea what to pass. So I think what I really should calculate something based on the things that we have seen along this direction, which is then still a single direction, but then going through a multi-dimensional space. But that doesn't matter in that case. I think reasonable would be to make a step. I'm still talking about a step though, not a fraction of something. But I'm also having a scale, so it's the scale that belongs to this direction, whatever direction we're going into. And I just want to go in that direction, a distance step. Yeah, yep. Okay, so it is what it is. Let's say my learning rate needs a new name, and I'm not going to multiply it anymore with a derivative because that's really nonsensical. 1/10 of the last scale. That seems very reasonable. So I'm using currently learning rate at several places. You see the unit of the thing is also completely arbitrary. They call it a rate, but it's actually not even dimensionless. No wonder everyone has to try. If you currently in machine learning, if they want to do something, then they have to just try it out. They start with some learning rate, and then they let the thing learn, and then they try another learning rate and see if that is better. It's not very efficient, if you ask me. So here I'm using it for the handle single sample. I'm using it the way other people use it, multiplied with the derivative. Here I'm using it as a step. It is also very arbitrary. Here I'm using it as a step. And that's it. Nice. Yeah, I like it when stuff is only used in very few places. So this is the problem, and here it is a step. Why not just, treat it as a step at all times? Let's rename learning rate to small step. We carefully want to examine what happens as a result of as a result of a small step. So basically, we want to probe the second derivative of the curve. Okay. Replace learning rate with small step. And then of course this does not make any sense anymore to multiply it with the derivative, except that it gives me a direction. Okay, but if I'm going to initialize small step after finding a minimum, then in the beginning we don't have it yet, so then I still have to do this. So I could initialize it to 0, and then I would still need a learning rate. I mean, we would still really arbitrarily start with some step. Or you can just ask, demand that it was initialized anyway. But then this would not happen, which is a good thing, I suppose. This is no longer true then, because you just made a small step and not looking at the gradient at all. Up, 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 up. Okay, let me keep learning rate. I just want to add something. Yeah, so if you get here, then age direction should be known. Because small step should only be, we are going to set small step only when it is known. Add an assert anyway. So age direction is on equal. What's it called? Undecided. I think anyway. Yeah, you would say that this is always true then. But okay. Right, now let's initialize small step then. So I think I can do that as soon as I have a scale. Or shall I just set it as soon as I have an age direction? I guess that would be here. Opposite, but it was unequal undecided already. Just change the direction. You did set for the first time. And this is in the function and the local extreme. So after we found the extreme, I should have a skill as well. Here's a skill. Here we have a scale. doesn't give me the scale. What the hell? I don't need I don't know. The word scale is in it, but no. What about just approximation then? Approximation pointer gives me an approximation which has a scale. There. That's what I need. Parabola scale, which has an automatic conversion, I think, to double. Or I can just call value on it. Yeah. Well, this returns the absolute value of the scale. That's what I need. So let's just do the automatic conversion. Parabola scale on whatever I jumped to, which is that thing. So don't even need to do that. Whoa. Well, no, never mind. I thought it was larger than 0.1, but now it's just a step. So yeah, 0.5 instead of 16, basically. Let's see how often it gets changed, or what it gets changed to then. 1.2. Again 1.2. And now 1. Perfect, man. Again 1. Again 1. No, 0.9 then. Yeah, it even it follows everything now. We don't have the weird jump that we had before. It finds all the minimum, maximum. Maximum, minimum, maximum, minimum, maximum, minimum, maximum. Way better behaves. Find this one. Dude, it even finds that one without any effort now. So much better. And now what happens? Clearly you have to go to the left still. Going to a minus 58. Wow, that's already pretty damn close to this thing here. So we're going to make a step towards still towards the left, right? Interesting. Oh, wait a minute. No. We're trying to find a minimum here. But we jumped over it and had to reset. So now it's a straight line. But then I think if I do one more step, now it sees that this is a parabola with a minimum all the way over here. And then it wants to jump to the vertex at 49. Oh, just, well, it's not 0 then. No, sorry. 49 is the label. It's at 0.29, so that's indeed here. And then I still need to add that code that it detects that then this point here does not fit. Actually, already I have to add that. It's a gamma thing. So we jump here and then it sees that this is extremely different from what we expected, namely somewhere deep down here. Expected minus 85. So that's small compared to the 1200, but okay. By coincidence, what happens? And then gamma best, it jumped back to minus 29, so that's here. I wonder if the backtracking works already, in the sense that it then detects that this still doesn't fit this parabola. And then it jumps back even further and further and further until we reach this point. Nope, they just did it one time. Well, that's no good. No, this point should never have been added, because we tried to jump to the vertex of some parabola. Actually, now we try to jump to the minimum of a third-degree polynomial that was fitted. But it's still far off. Far off. And we go all over the place. See, now you get ridiculous stuff as this. We got here, and that fits a parabola through this point and that point. Then you're doing something that you should not be doing. And then the debugger opens. Right, because okay, still went to the left and then saw that this is no longer part of that parabola, because the parabola was nonsense in the first place. And then it starts over again. Now we find the parabola again, and it doesn't get any closer than here. Yeah, it's just nonsense now. Erratic jumping. Let me go faster and let's see what happens. Oh, it stops. The lowest minimum. This is the lowest minimum that I did find. Oh, right. difficult. Okay, there is something that jumps out here to me. Namely, why the hell would it return this when there was a sample that was lower? That wasn't detected as being a minimum, but it is definitely still lower. Alarm bells should be going off. Like, okay, there is this is a minimum according to me, the derivative 0. It's the best minimum that I found. But I have a sample that is even less than that. So that means there is another minimum, right? I mean, don't give up. That's really wrong, yeah. It kind of should have detect here that this can't be the best minimum. But the real problem, of course, is that it just couldn't find this minimum once we got here. So what happens if we find the 51, just jumped over it, and then we find the 52. I have no idea why I would find the 53, really. I would say the 51 and the 52 together is already a parabola, though it has the vertex over here. And then it should go that way. The whole purpose of this particular function here, the aka test, is that this parabola has a minimum all the way over here. And then it should detect that this curve has nothing to do with that parabola, and therefore backtrack until it does. So we probably find maybe something that's less than 10% off, so I don't know, maybe this point here. And it's going to have a hard time, but well, eventually wanted to find that point. Definitely wanted. This is an extremely nasty function because my algorithm kind of assumes, I have to admit, that everything is a parabola if you zoom in close enough. And that's probably also the case here, but then you have to zoom in to the very, very, very top, because it is a parabola all the way up till here, and then in a super short time we go from parabola to sinus, like a really short time. So that's extremely nasty. Yeah, I'm going to make breakfast. It's 2 p.m., so it's about time. So I'll be back later. We'll get there eventually. Hi Jonas. Sorry man, I'd switched my music, so I went to the tab of Spotify and I missed what you said. Gradient descent is, well, you can better look it up, just Google it, or on YouTube or something like that. Well, no, actually, it's so easy. I can just explain it. The gradient descent basically means, in this case, we try to find the minimum of an unknown function. But the gradient is in the derivative, so the slope, how steep something is. And the way people usually do that is that they are on this slope and then just descend. So they follow the gradient or the derivative down until they find the minimum. I'm doing it on a totally different way. So it's hardly a gradient descent anymore, but the objective is still to find the minimum. So I should remove that debug thing. I have two of them in it. What is this? Yeah, that doesn't happen anymore. Okay, I moved that as well, I guess. Touch. Now, the thing is that it is expensive, say, in terms of CPU, that to make a new probe. Sorry, let me start it. So every time I have to evaluate for a certain value of w what the height is of my unknown function and the slope of it, so how steep it is, or first derivative, or in a multi-dimensional case the gradient, that's expensive. So if you are like here and you descend carefully a little bit, and then again a little bit, and 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 then the shallower it goes, the less steep the function is, the smaller steps you make. So less, and it takes infinitely long before you reach the bottom. Because, yeah, every time you make smaller steps, because the gradient is less and less. And I thought that's stupid, because any reasonable person sees that almost everything is, if you zoom in close enough, is like a parabola. So with just 2 points, you know exactly what the vertex is. So that's what I'm doing. Go closer so you can actually see something. So for example, we have here, that's fast. You can hardly see it. Sorry. In this case, this is not a good example, but say you have a point here and a point here, so then you have a parabola already, and then you jump to the vertex of the parabola. Oh, here you see a parabola, okay, but then we jump to this vertex, which is now nonsense. Well, by looking at not one point and just its derivative, but by looking at 2 points and their derivative and the change in the derivative, I can much faster zoom in on the minimum. If the function locally can be approximated with a parabola. And it should be, I think. So that's that was my idea behind this. And it works in other cases, like more sensible cases. I'll just show you one more example for where this actually works, because this is already a very difficult case. Where my algorithm breaks down deliberately. I think that's the easiest one. Okay, so here we have a simple case in that this is a parabola, and then around 0 it goes to another parabola. So actually this is a parabola, and this is a parabola, and they just suddenly switch from one parabola to the other. So that was already a nasty check. And we start here, and then we go, well, we find this parabola. Just this point, 0 and 1, is enough to find the parabola, because all of these points are on a parabola. So thinking now, looking locally here, and thinking that it is a parabola, we jump to the vertex here. Yep. And then it says, oh, wait a minute, I expected it to be here, but it's a little bit lower. So let's plot a third degree polynomial through this point and those two. And then I would expect the minimum to be there, actually. So now it's going to jump here. And now it plots a parabola through point 2 and 3. So now that's on the left side of the 0. These are now forgotten. So now it finds the other parabola. And then it jumps to the vertex of that, which is indeed the minimum. So bang, that's super fast. We just have 1, 2, 3, 4, 5 samples and we are there. And yeah, that's, I think, I mean, like 6 digits precision. But of course that's because it is exactly a parabola. It's not really very honest, but still, it's just, in general, it's a symmetrical function, left and right, that finds it really fast. And I think a lot faster than current methods with just gradient descent. But that's just a local minimum. There could be another minimum over there, you know, so it fits a 4th degree polynomial now to find which way to go, and then it decides to go that way. And then it goes up till here, which is higher than the maximum energy that I allowed. So if it goes up this high, then we just stop. Then we're not going to explore further to that side. But then there could still be a minimum on the other side. So it just goes back here and explores that as well. And that goes also above the energy. And then we went left and right above the maximum energy. Therefore, this is the minimum. Was indeed the minimum then. So that's 10 samples. Well, not bad. Okay, let me go eat. I'll be back later.